And if I get to number 22, the same deal. This is going to be f of 1 minus f of 0. What's f of v in this case? That is v minus, add 1 to the power divided by that. Add 1 to the power divided by that. I'm so stuck on x. Sorry, guys. So, f of v is v minus 2v to the 4th plus 2v to the 8th. F of 1 is actually 1 minus 2 plus 2, that's a 1. F of 0 is 1 minus 2 times 0 plus 2 times 0, that's a 1. So this is 1 minus 1, that's a 0. The answers are not always this nice, but you know, it could be. The next problem, the same deal. We're going to say this is, and you start kind of playing with this, and instead of saying f of 4, which you always can, you would say this is, let's see, the integral from 0 to 4, that is 4t to the 1 half minus t to the 3 halves dt. That's going to be 4, add 1 to the power, divide by that. Add 1 to the power, divide by that, right? And instead of writing this, we start saying evaluate it from 0 to 4. That is 8/3 times the square root of, and we plug this in first, 4 cubed minus 2/5 the square root of 4 to the 5th minus, and you throw the 0 in. You could, of course, do that anytime you want, but that's really how we start doing the problems all throughout. Square root of 4 is 2 cubed, that's 8. Square root of 4 is 2. 2 to the 5th is, what is that, 32. So this turns out to be 64 over 3 minus 64 over 5. Now on a test, that's a fine answer. That will be 5. That's 5 into 64 minus 3 into 64. Actually, that would make that 15. And since they're both 64s, wouldn't that be over 15? 5 of those minus 3 of those is 2 of those. And there it is. 128 divided by 15. Not a big deal. With a calculator, you can get that easily. Same deal here. We're trying to figure out how this works. Well, again, if you want to keep on using this, you can in this section at least. Once you get the hang of this, we start really, it's the same thing, just writing this and proceeding down. So, f of theta, what do you take a derivative of to get cosecant squared? That's cotan of theta, but with a negative. If I figure out what f of pi over 3 is, and in case you've forgotten from back in the days, there's 30, 1, 2, radical 3, and pi over 6 is right there. Pi over 3 is right there, I'm sorry. So f of pi over 3, that would be the cotangent, and that would be 1 over radical 3. And f of pi over 4, well, we know at 45 degrees that's a 1. So this is actually a negative 1 over radical 3 minus a negative 1. That turns out to be negative 1 over radical 3 plus 1. That's a fine answer. Could get a common denominator, rationalize, do all of that stuff. But there it is. It says on number 47, evaluate the integral and interpret it as a difference of areas. Illustrate with a sketch. Well, we'll do the sketch in a minute, but for now, wouldn't this be, what do you take a derivative to get cosine? The sine of x evaluated from pi over 6 to 2 pi. Wouldn't that be the sine of pi over 6 minus? I got it backwards, didn't I? Isn't that the sine of 2 pi minus the sine of pi over 6? Well, that would be a 0 minus, and pi over 6 is right there, sine is 1 half, and that would be a negative 1 half. Well, let's see how that works. If I take the graph of a cosine, cosine starts at 1, right? I'm going to make that a 1. It runs down to the amplitude, back up to the starting point. So the graph looks something like this. I'm really looking at this between 2 pi, that's pi over 2, but I'm running from pi over 6. That integral is going to actually figure out and do we notice that this area here beneath is actually equal to this area if this was to start at 0? If I was to start from the beginning, then that integral would have zeroed out. The area above and the area below would have matched. But the fact that I started at pi over 6, it seems now the negative area underneath is bigger, so it outweighs the positive, and that's why the answer is negative. Alright? Next problem, they ask, what is wrong with this equation? Somebody did this integral. They took 4x to the negative 3, isn't that right? And they said, add 1 to the power and divide by that. And those reduced by 2. That's negative 2x to the negative 2. Isn't that negative 2 over x squared? So yeah, they got it right. And they threw the 2 in. What is f of 2? Isn't that negative 2 over 4 minus f of negative 1? Isn't f of negative 1 a negative 2 over negative 1 squared, which is 1? Isn't that a negative 1/2 plus 2, and that's a 3/2? Yeah, hey, it seems to be fine. Why are they saying there's something wrong with it? Well, what's the one condition for you to integrate? This must be continuous. If I look at the graph of this, and since I can graph anything in about 5 to 7 seconds, give or take, so since the graph looks like this, and I'm trying to find the integral from negative 1 to 2, do you see what's wrong with that picture? Do you see this is not continuous at x equals 0, and 0 happened to be in there? The only condition for me to use fundamental theorem of calculus, so none of this applies, and work this out, is for this function to be continuous on that interval. It's not continuous, I can't use it. And this problem is more of a bonus problem. It says evaluate the limit. Let's see if you remember how that works. Evaluate the limit by first recognizing it as a sum, by recognizing the sum as a sum of Riemann. They have a limit as n approaches infinity. Riemann. So do you notice what's changing? Can't I say that's the series from I equal 1 to n? It runs from 1 to n. Of what? I? Well, think about it now. I'm comparing that to the limit as n approaches infinity of the series I equal 1 to n of f of x sub I delta x. Can you see where delta x is? Delta x equal 1 over n, and that's b minus a over n, so I know b minus a equal a 1. Very good. And I know that x sub I is a plus I times delta x. In our case, we do not know what a is, but delta x is actually, we got it to be 1 over n. So I'm trying to figure out a plus I over n equals I over n. Doesn't that mean that a must be 0? There's no a there. And if a equals 0, and I know the length of the interval is 1, doesn't that mean b equal 1? And isn't that a Riemann sum? What does that mean? Instead of doing this work, can't I say this is actually by the Riemann sum, the theorem 2 was it, or definition 2? This is the integral from 0 to 1. What's the function? radical x dx. Wouldn't you say that's x? So it's x to the 1/2. Add 1 to the power, divide by that. Evaluate from 0 to 1. Wouldn't you say that is 2/3? And there's your homework in this section.